Hello, can everybody hear me?
Yeah,
Yeah, and my screen shared, right?
yeah.
Yeah. Today, please keep a pen, pencil, and notebook with you, whatever pen or pencil and notebook, because we'll do some numericals, so you might need it. And
Yeah.
I already shared the presentation with you on the Achyutam group.
कधी आता पाठवलंय?
हो,
ओके.
सेम आहे.
हं?
सेम आहे.
हं. So let's have prayers, no, ma'am? Archana, ma'am,
Yeah.
please.
बोल.
बैठ जाएंगे किसी भी ध्यानात्मक आसन में। पीठ गर्दन कमर एक लाइन में, आंखें कोमलता से बंद, मन एकदम शांत, हाथों की प्रणाम मुद्रा। एक गहरी लंबी सांस लेंगे और धीरे धीरे छोड़ेंगे। एक मध्यम पट्टी का ओम उच्चारण करेंगे। ओम। या कुंदेन्दु तुषारहार धवला, या शुभ्रवस्त्रामृता, या वीणावरदण्डमण्डित करा, या श्वेतपद्मासना, या ब्रह्माच्युतशङ्कर प्रभृतिभिर्देवै सदा वन्दिता, सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा, निःशेषजाड्यापहा। इस प्रार्थना को सरस्वती माता का ये जो शुभाशीर्वाद हमें दिए हैं, उस भावना को फील करते हुए दोनों हाथों को एक दूसरे पे रब करेंगे और इस पॉजिटिव एनर्जी को अपने आंखों पे लगाएंगे और कोमलता के साथ एक स्माइल के साथ अपनी आंखें खोलेंगे।
Thank you.
Thank you. Thank you, everybody.
Thank you very much.
Okay, so 5 people are there. So can we start?
Yeah.
चालू करूया, झाले
हम्म.
2.
So you can see the presentation on my screen right now.
Yes.
Okay. So yeah, good afternoon, everybody.
Good afternoon.
Yeah. And greetings and respects to all the teachers, and we'll start now. Yeah, this is again the syllabus. Yeah, so today to start with, we will learn about language processors. So language processors, these are, I mean, of course, there is some hardware there, but these are all in the form of software. Major part is in software form. So like you can think about hardware as kind of the nerves running in our body. And then there are also some nadis. So I always think of this nadis as the software. Like you cannot physically feel, you cannot physically touch it, but you can feel their presence everywhere. So these language processors are like kind of the nadis. So there are three types: assemblers, interpreters, and compilers. And the main use is like when we are giving instructions to the computers, as a layman, the end user always like gives some human readable instructions. Like even now when we are using the latest technology, that is AI. Like if we are giving any instructions to chat GPT or Google Gemini, we are giving human instructions, the prompt which we as human, a layman, can understand, but computer interprets it and gives the technological inputs to the other side of the computer, and then it gets the output for us, which is again in human readable form. So though that all is taken, that all translation from human readable instructions to the technical instructions is taken care by language processors. So first type is assembler. So this language processor converts the program written in assembly language into machine language. So there is another language, like right now I was referring to the human language. There is also assembly language, like which is only understood by the technical people. So that is in the form of like ABCD and 1 2 3. So the assembler converts those instructions also into the binary form 0101 for computer to understand. Then there is second type of language processor, which is interpreter. So this language processor now converts an HLL language, HLL, that is high level language, like the language in which we human beings speak. We give the instructions to the computer, so that program into machine language by converting and executing it line by line. So this interpreter, it will take our like higher level language, that is human readable language, and convert it into machine language. And how it will do it? It will do it line by line. And then there is another third version of language processor, which is called compiler. So it also converts the HLL, that is the human readable high level program, into machine language. But now the conversion manner is different. Like it converts the entire HLL program, human readable program, in one go and reports all the errors of the program along with the line numbers. So this compiler is like interpreter was converting one line by one line, and compiler will take the whole chunk of like whatever prompts we are giving to the AI and straight away convert it for the machine to understand it. So these language processors come in the exam, and they will give you description like about the assembler, interpreter, and compiler, and they will ask you to either match the column, match the correct options, or select the correct option. So you should know. Assembler will convert assembly language. Interpreter will convert human readable high level language to the machine language, but it will do so line by line. And compiler will take the entire set of instructions, human readable instructions, that is HLL, and the whole lot it will take at one time and give it, convert to the machine code. Then classification of computers. So we generally use all these like PC, laptops, PC, desktop. So PC is personal computer. So it is a single user computer system having moderately powerful microprocessors. This is a PC we most of us have used at our homes. Like I myself even now have a PC. So that those big box PCs, computers which we used to use at home, where the personal computers, and they too have a powerful microprocessor. Then workstation, it is also a single user computer system which is similar to personal computer, but workstation will have more powerful microprocessor. Then mini computer, it is now, this is multi-user computer system. which is capable of supporting hundreds of users simultaneously. So like there will be a big server somewhere, and there will be many machines connected to that one server. And so like usually we will find such setups in banks, stock market, where there will be one big server and all other people will be using, will be connected that to that huge server using the small computers. So that is, so that's why it is said multi-user computer system. So many people get hooked to that one single computer. Then is the mainframe. It is again a multi-user computer system which is capable of supporting hundreds of users simultaneously. When we read this word mainframe, means banking. All our banking system works on mainframe computers only. Then supercomputer. So it is an extremely fast computer which can execute hundreds of millions of instructions per second. So these are huge computers, like they may be the size of a room as well. That kind of huge computers even used today, but that are used like in military defense setup, like which have very limited access. And India has developed one supercomputer which is called, I think that Param supercomputer. So this is about the classification of computers. This also usually comes in the exam, and like questions are like which is the microprocessor which is used in the PC and workstation, which is faster. So you should be able to answer such questions. Like personal computer will be the slowest. Above that, workstation will be little bit more faster. Mini computers, medium range speeds, and mainframes and supercomputers are extremely high speed computers. Then we'll go to the memory storage units. Yeah. So actually, as such, memories for a computer is very complicated thing, but for our net UGC, we'll be doing very basics of it. Because right now, what memory is in use in today's computers is, this is totally different. This is something 10-15 years old theory which we are studying now, but since it is in our exam, we have to study it. Okay, so right now, like the speed at which we are getting the output from like our mobile phone, which is also a computer. So it is using totally different technology, but we'll just read the basics of it, study the basics of it, just to get the exam, get the UGC exam questions right. So the basic unit here for a memory is bit. That is a binary digit. So like you can think of it like,
इधर आओ लिखो.
hello, who is this, please?
सर म्यूट कीजिए
Can
प्लीज.
you mute yourself, please? Yeah. So a binary, the lowest memory unit, like for human body, we say lowest unit is a cell. If we take a like a scale, which we generally use at home or use in the school or colleges, we say that the lowest unit is like 1 millimeter, 1 centimeter. So like that for memory also, the lowest unit is bit. It is called bit. The memory cell is bit. It's a binary digit. So a binary digit is what? It is a logical 0 and 1. It could be like the power also, the switch on off, like 230 volts or 0 volt. That also can be represented by 0 and 1. So it is logical 0 and 1 representing a passive or an active state. 0 is called passive state, 1 is called active state. Like 230 volt when we are supplying, we say that it is 1, it is active state. And when we do the switch off, then the voltage is 0. Then we say, okay, passive. Now we have switched off. It is passive. So it's a state of component in an electric circuit. So this is operating at the lowest level. It is an electric circuit only. Whether it is like embossed in the semiconductor IC, or it is a physical hardware, it is always some electric circuit only. And it will do on, off, and this on is 1, off is 0. So like that only conversion happens. And whatever, like when we talk about like stock market today, we are giving the figures in millions and billions, but computer is not bothered about whether you are talking about millions and billions. It understands only 0 and 1. So for computer, it is only just 0 and 1, and it has its arithmetic logic unit, which sees to it that there will not be a single mistake in the mathematical calculation. And for computer, it is only 0 and 1. So that by that lowest unit is bit. So it is represented by a small square. I have shown here in that table. Yeah. So it is just like, to imagine, it is just a cell, just a basic cell, which is called bit. Then above that is nibble. So after a bit, it is nibble. So it is a group of 4 bits. So a group of 4 bits. Earlier, a single bit I have represented by a single square. Now 4 bits I have represented by using the 4 squares, right? So 4 bits is a nibble. So these all questions come in the exam. Like how nibble is how many bits? The nibble is 4 bits. Now we go above it, then it is bytes. So a group of 8 bits is called a byte. So 8 such cells, 8 such squares have come together to form a byte. So a byte is the smallest unit which can represent a data item or a character. Now we were talking about bit and nibble, and now we are saying byte, which is 8 bits. So when we want to represent a single character, say alphabet A, B, or number 1, 2, then to store that, we need 8 bits, minimum 8 bits. So to store one character, we need 8 bits, which is also called as a byte. Then comes the word. Now a computer word, like a byte, is also a group of fixed number of bits processed as a unit, which then again varies from computer to computer, but is fixed for each computer. So the length of the computer is a word is called as word size or the word length. And it may be as small as 8 bits or maybe as long as 96 bits. A computer stores the information in the form of computer words. So for storing words also, computer uses like a bunch of bytes, which are in again like a group of bits only. So then, like now they have given example of 8 bits and 96 bits. But again, now the way at what speed we are going, I think the 8 bits and 96 bits might be very small. They must be using thousands of bits as a computer word these days. So we, for memory storage units, we have seen 4 bit, which is a binary digit, which is a single bit, 0, 1, 0 or 1. Nibble is again a group of 4 bits. Then comes byte, which is a group of 8 bits, right? Which 1 byte is equal to 8 bits. And then computer word, which is like they say, it differs. That length is not fixed. It differs. Like some might be 8-bit computers, some might be 96-bit computers, and so on. And so here nibble is 4 bits and 1 byte is 8 bits. So 1 byte is equal to how many nibble?
64.
2 nibbles. 4 bits is 1 nibble. So 8 bits is 2 nibbles, right?
Yeah.
So 1 byte is 8 bits, but they won't ask the direct question. They will ask in terms of nibble. So when 1 byte is equal to 2 nibbles.
Nibble, barabar. Nibble 4. Okay.
Yeah.
Okay.
And words, they have not given any. Computer word size is not fixed. So questions won't come in that. Then is the unit. Like we are generally used to the units like grams, milligrams, kilograms. So here for computer, that unit where we start is kilobyte. Okay, 1 kilobyte, which is represented as how we represent 1 kg. Like that, here it is 1 kb. Okay, and 1 kb, generally we are used to that, 1 kg is equal to 1000 grams, right? So here like that 1 kilobyte is straight away 1024 bytes. Bytes means how have we come to this 1024? 2 raised to 10. 2 to the power of 10 is 1024. So always when we talk about computer storage units, we'll start here. 1 kilobyte, like 1 kilogram is 1000 grams. So here 1 kilobyte is 1024 bytes. Okay. Here it starts, the unit starts. Then we go to the higher end, like 1 megabyte. That 1 megabyte is 1224 kilobytes. Then we go to the next higher, 1 gigabyte. So gigabyte is again 1024, that previous one megabyte, here 1024 megabytes. Then we come to terabyte, that terabyte is the previous one, 1024 gigabytes. Then petabytes. So 1 petabyte is 1024 terabytes. So these conversion, this relation you have to logically remember it. Okay. Kilobyte, megabyte, gigabyte, terabyte, petabyte. And they are that 1024 is 2 to the power of 10, like 2 multiplied 10 times. Not 2 times 10. 2 times 10 is only 20. It is 2 times into 2 times done 10 times. Then you get this number 1024. Yeah, we use that 2 as a base because all the computer system is based on binary only, 0 and 1. That's why that 2 comes into picture. That small square as a bit which I showed you, it will hold logical 1 or 0. Like we have switched on a switch, electric switch. That means the voltage is 230 volts. That means the bit is 1. So that's why they take 2 to the power 10. 2 to the power 10 in the case like below this, it will be very less data it can store. We will use computer, we will not use computer like a calculator only. We will use computer for some complex task. That's why we start from 2 to the power 10. Less than this, I think, must be available in the toy laptops or toy computers which the children use. Then software. So software represents the set of programs that govern the operation of a computer system and make the hardware run. And then again, there are two types of softwares. So softwares are like they are, it is not in the form of hardware. They are the logical instructions given to the computer. And in that also, there are two types of software, the system software and the application software. So system software is a collection of programs designed to operate, control, and extend the processing capabilities of the computer itself. So we get a hardware box with certain instructions already fed to it, but we want to enhance that computer so that we can use for our own customized purposes. And then that's why we have to upload softwares on it. Then system software are generally prepared by computer manufacturers. System software serve as the interface between the hardware and the end user. Example is operating system, compilers, interpreters, assemblers, etc. So these system softwares we have to use because we have to use some interface between the hardware and end user. If this system software is not used, then we can imagine like earlier we used to have those telephone exchanges, and those ladies used to sit there, computer operators, and they used to handle so many switches to connect the calls to each other, different users. Like if we don't have this software, we would also be given like hundreds of switches, and we have to do somebody wants Excel, switch on, make this switch on. Somebody wants PowerPoint now, switch, do this switch off, do that switch on. So like that we would have handled those switches. So that is done with now, and we have got softwares as a layer in between which is doing all that switching. And system softwares are operating system compilers. These are like like we have involuntary systems in our body, like our like breathing, which is involuntary. Even if we forget to breathe, the body breathes for us, right? Otherwise we will die. Similarly, these system softwares are there. Like even if we give instructions or not, behind the scene they are doing all the processing. Okay, operating system, it is operating for us. Compilers, interpreters, like right now also we are using a software to do this video conferencing, but behind the scene there are so many compilers, interpreters, assemblers, operating system doing their job and converting this data into 10101 and transmitting it so that I am speaking and you are able to hear. So all this is taken care of by system software and obviously the hardware. Then is the application software. It is a set of programs necessary to carry out operations for a specified application. Now is application software. This is voluntary. Like yesterday also I told you, I have made a document. I want to make a PowerPoint presentation. Then it's my responsibility to tell the computer that use PowerPoint now. to do a presentation for me. So that is application software. Here the end user has voluntary control. He can select a PowerPoint. The end user can select Word depending on the requirement, what that particular end user has. So that is application software. So that is voluntary control. System software, it is involuntary control. It is operating system is the example for it, and it is working on its own in the background. Then application software. There are three categories. We said applications software that they are a voluntary control which the end user has, and the end user selects the software based on what output he or she wants. So then again, these application softwares, there are categories in that, right? So then there are packages. So we have word processing package. The best example is Microsoft Word, which is a word processing package. Then there are text editors. These are all word processing packages. As the name suggests, they do word processing. A package that processes textual matter and creates organized and flawless documents. And again, to note one thing is these kind of applications are called, they are all application softwares, but they are also called packages. So like this can also come in the exam with that name, packages. So word processing. Then spreadsheets, the MS Excel is a spreadsheet package. An electronic spreadsheet is a program that accepts data in a tabular form and allows users to manipulate, calculate, analyze data in the desired manner. So that kind of softwares are called spreadsheets. Like there are thousands of packages, but as a common man, we are only exposed to my MS Word, MS Excel. Then database management system, this is DBMS, is a package that can handle and manage bulk of stored data. So DBMS are data storages. So like MS Access, Oracle, Microsoft SQL, these are all databases. Then desktop publishing softwares handles page layout by combining the functions of a traditional typesetter and layout artist. So like newspapers, earlier we know that new printing newspapers used to happen in those small shops. Now that all is taken care of by desktop publishing softwares, DTP softwares. So they will handle all that formatting very easily. Then graphics, multimedia and presentation applications. So these presentation applications, PowerPoint, Photoshop, graphics, multimedia, all these applications, softwares that manipulate images, they are all graphical softwares. Microsoft Paint, which we commonly have on our PCs. Then are the utilities. So again, utilities are those application programs that assist the computer by performing housekeeping functions like backing up the disk or scanning viruses. Again, this will be handled involuntarily. Like if we install like a antivirus software like McAfee, but what if we forget to start it? It is like the virus will come and infect our computer. But then these are all come under the utility softwares. So the operating system will take care of switching them on and catching the virus and deleting that particular or quarantining the computer from that particular virus. So that utility softwares are packages are again they work voluntarily, involuntarily. Then there is a in that text editor, sorry, text editor is there. So text editor is used for creating and editing text file. Text editor, obviously we start by ourselves, but sometimes there are error messages or something coming up from the background, from the operating system, from the backend. Then text editor starts automatically and it reports that error to us. Then backup utility, program facilities. Just a minute. Huh? Sorry. Yeah. Backup utility, which do the backup of the hard disk. Like sometimes, like we are doing some work and there is a power failure, but still sometimes we find that our data has got saved. So then backup utility softwares, they switch on by themselves and do the backup. Then compression utilities, these are for compressing the large files. Then defragmenters, like sometimes when the data gets scattered on the disk and the computers become slow, we do the disk fragmentation, and sometimes even operating system does this automatically. Then there are antivirus softwares, like we buy antivirus packages, and they are also like involuntarily switched on and off by the operating system. And also we also set up the times, like every weekend or every 24 hours, the antivirus software can scan our laptops or PCs. Then there are customized softwares, like this type of software is tailor-made software according to a user's requirement. These are like softwares done by for individual users, or like a group of users, or small shops or small CA offices setups. They get their own customized softwares done for themselves. Now we'll come to the number system, right? So so now we'll do some numericals also, but I will read out some theory, but there are figures which are self-explanatory, but I'll read some theory. So when we type some letters or words, the computer translates them in the numbers, as computers can understand only numbers. So even if when we are typing anything, computer has to get the final instruction in 1001. So a computer can understand positional number system where there are only a few symbols called digits, and these symbols represent different values depending on the position they occupy in the number. A value of each digit in a number can be determined using the digit, the position of the digit in the number, the base of the number system, where the base is defined as the total number of digits available in the number system. Like this was theory. I'll go to the other screen. Yeah. See this number system. So now we have what? Decimal number system, which we have been using, like we learned to do in maths using the decimal number system. Whether it was any vernacular medium, whether it was in English, we started using decimal number system. Okay, so that decimal number system has base 10 always, but since it's default, we never say that this is base 10, but whatever numbers we are using, it always has a base 10, and the digits that we all know, so as of now, is only 0 to 9. The numbers can be huge or infinite, but the digits are only 10. They start from 0 and end in 9, right? So this is the number system that we know. We are very much familiar with decimal number system, and we will study the other number systems in comparison with the decimal number system only. Okay?
Yes.
Yeah. So
Yes.
now first is binary number system. Like since yesterday I'm saying only the computers understand only 0, 1, 0, 1. So computer understands only 0, 1. Human beings understand decimal numbers. We human beings understand 0 to 9 numbers. And 0 to 9 digits, I mean. And computer understand only 0, 1. And so their base is 2. Because like this is Dwight 0 and 1. So Dwight base is 2. Okay. And then octal number system. So now computer wants everything in 0, 1, but only 0, 1 when with the base 2, the numbers become huge after a certain point of time. That's why they were come up with octal number system, where the number digits are only from 0 to 7. So it is base 8. And then there are hexadecimal number system, which is base 16. So there are digits 0 to 9. And also now to take care of the higher numbers, they have introduced alphabets A to F to represent the numbers from 10 to 15. Okay. So these 6 digits from 10, 11, 12, 13, 14, 15, they are represented by A, B, C, D, E, F. Okay. So 4 number systems: decimal number system, base 10, 0 to 9. Binary number system, base 2, by 2, Dvait, 2, base 2, 0, 1. Octal, 8, octal is 8. So base 8. So when we say base 8, numbers start from 0 to 7. Then hexadecimal. Hexa is 6 and decimal. So decimal it is using, for decimal part it is using 0 to 9, and hexa 6, next 6 digits are represented by 6 numbers are represented by alphabets A to F, and so base is 16. So that is hexadecimal. So these 4 number systems you have to remember from the UGC point of view. Then there are other number systems also, ASCII, and there are so many other number systems, but they are not in our syllabus. So again, types of number system, I have whatever I have said, I have like given in the notes form here. You can read them later. Then here again I have said base binary 2, octal 8, decimal 10, hexadecimal 16. So base you should know. Base numbers and their representations. So this can come in exams. Like for hexadecimal number system has, what is the base of hexadecimal number system? So you should always remember hexa and decimal. So decimal 10 part 0 to 9 and hexa 6. So 16. 10 plus 6, 16. Octal itself means 8. Octa is 8. Decimal, deci 10. So 10. Binary, Dwight 0, 1, 2. Then like to compare, if we keep this decimal, binary, octal and hexadecimal numbers in the table, then we can see decimal number system. This is what we have learned since our childhood. 0, 1, 2, 3 calculation, 0 to 16. Then here binary, like 0 gets represented in all the number systems as 0 only. 1 as 1, 2 in binary it will get represented as 1, 0. In octal it will be 2. In hexadecimal it will be 2. So see how in binary from 2 onwards the number representation becomes 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. And octal, how it is from 0 to 20, and here hexadecimal 0 to 9 digits and A, B, C, D, E, F. Then numericals come in the form of number conversion problems. So the most basic part of it is to convert decimal to binary and binary to decimal. Actually, why we are doing it? Because we want to facilitate the computer hardware to understand. That's why. But like as a end users, this is of not much use to us. But since it is a part of UGC exam, we are just going to look at it. These are the steps I have given. You can read them later. Then here I have shown the decimal number system, like which is in use in India. So this is units place, which is 10 to the power of 0. Tens place 10 to the power of 1. Hundreds we say 10 to the power of 2, like 100. 1000 10 to the power of 3, 1000. 10,000 means 1 and 4 zeros. So 10 to the power of 3. 10 to the power of 4 is lakhs. So 1 lakh is 1 and 5 zeros. 10 lakhs, 1 and 6 zeros, right? So 10 and another 5 zeros, 10 to the power of 5. So like this is the number system which we know, like crores, then 10 crores, then arab, then 10 arab, then there is kharab and 10 kharab, like that is it goes on and on. So if we are given a number here, like 1000, like this is, we know a number which is till now we know 1 and 5 zeros, means we will say, okay, this is 1 lakh. 1 and 5 zeros, 1 lakh. So what is it? 100 add to the base 10. But since this is default, we don't say this base 10. When it is 100 and base 10, then we have 1 lakh. Now, since we are entering the computer arena, we want to get familiar with the binary system. That's why like you can learn it in a comparative way. So here how our decimal system started with 10 raised to 0, 10 to the power of 0 in the units place. So here computer system starts with 2 to the power of 0 in units place. Then it goes to 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, and so on. So if similarly, if we are given this number 1 with 5 zeros, but this time we are told, okay, now the base is 2. Now the base is 2 means this number is not 1 lakh, because now base is changed. Base is changed to 2. So we'll see where it fits. 100. So we'll start writing in this table. 000, 4 zeros, and this fifth digit 1. So it comes under 2 raised to 5. So 2 raised to 5, that is 2 multiplied 5 times by the self. 2 into 2 into 2, 5 times. Then the answer comes to 32. So 32 times 1. So the value of this same 1 with 5 zeros when the base is 2 is 32. So like this is how the number conversions happen. And why we are doing it is because computer wants it in 0-1 format. Now here I have given one example of decimal number 29 to the base 10. Like this is the normal number 29 we know, and we want it to convert it in, we want to know the binary equivalent of it. This is like, you can take the pen and start doing this calculation. I will tell you the steps. Okay, they are all given in this table. If you do it by yourself, you will understand it very easily. Okay. Shall we start? See the
Yes,
step.
ma'am.
Yeah, the step one is, this is in the table. Say there are steps. Steps 1 to 5. Then there is operation of division that we will do, the quotient and remainder, and then we will see how we form that binary number. So to start with 29, and we have to convert to what? We are in base 10 and we have to convert to binary. So our base is 2. So we have to start dividing that decimal number. Decimal number is the all the numbers that we know so far by 2. Yeah. So you can start writing. You write 29 and write divided by 2. Okay. So the quotient that comes is 2 ones are 2 and 2 twos for 9 will be there. Then 9, 2 fours are 8 and remainder is 1. Have you done this step? You
Yes,
start
ma'am.
writing.
Yes, yes.
Start writing like this.
yes.
Start writing like this table only, right? The steps after each other, like in the table form only. Okay. Then you got this quotient as 14, right? In step 1. So you now come to step 2. So 14 is bigger than 2. So again divide that 14 with 2. Then you got the quotient 7 and you got the remainder 0. Write the remainder in the remainder column. Okay. Now we go to, now this 7, it is bigger than the base 2. So again we'll take, see we are dividing, we go to step 3, we are dividing quotient by 2 again. So 7 divided by 2, quotient is 3, remainder is 1. Again we'll write that remainder in the remainder column. Then 3, which is again now bigger than 2. So we divide 3, the quotient, by 2. Then by the base 2, then we get the quotient as 1 and the remainder is also 1. So now when the remainder is less than 2, what we do is that last step we'll say, okay, quotient is now 0 and we straight away take that quotient as a remainder only, and then we'll go from bottom up and we'll form the number like 1101, and that 1101 is the binary equivalent of decimal 29. This, I think, if you do it with hand, then you will come to know.
Yes. Kiya.
Yeah, you have to keep dividing the quotient until what point? Until the quotient becomes less than the base. So because this base is 2 here now, but when we go to the octal numbers, base will become 8. So we have to divide by 8. Okay. When the question is like convert to hexadecimal, then you start dividing by 16. Until what point you will divide? Until your quotient is less than 16. So that depends on the base. And then you better to write these numbers in the tabular form only, and then just go bottom up. Then you get the number in the correct like sequence. Otherwise, if you start from the top, then that number will be wrong. So better to solve this in the tabular format only. Then you will not go wrong. Then the next is we did decimal to binary. Now we'll do to binary decimal. I have given the steps. You can read them later. So I have done this one problem for you. Now it is binary number. Okay, 1101 to the base 2. This is what computer understands. But now we want to convert it into decimal equivalent because we want to understand what this number was. Okay, so again we will follow that tabular format method only. Okay, so now when we are going from binary to decimal, decimal number is something which we know, like our numbers. Okay, end users numbers. So how we convert? The base 2, we take whatever the base is. Now here, because it is binary, base is 2, we take the base, we take this digit from the left hand side now. So it is 1. So 1 into, so how much it is? 2 to the power 4, because how many digits we have here? 1, 2, 3, 4, 5. So this lowest unit number the power will start from 2 to the power 0 from the right hand side. Then 2 to the power 1, 2 to the power 2, 3, 4. So when we start writing, like what we say in our Sanatani, we are always used to writing from the left hand side, right? We start from the left hand side of the page to write in our Sanatani style of writing. So we'll follow that format only. But now, a calculation we have done from the left hand side, right hand side. Okay. So we know the highest power we required here is 4, because there are how many digits? 1, 1, 0, 1, 5 digits. Okay. But the lowest unit starts from 2 to the power 0. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. So first leftmost digit we took, we said 1 into 2 to the power 4 plus the second digit was 1 again. So we said 1 into 2 to the power 3. We write these brackets because this will help us to do the calculations. So next we said another third digit is 1. So 1 into 2 to the power 2. The fourth digit is 0. So 0 into 2 to the power 1, and the last digit is again 1. So 1, but now the power of 2 is 2 to the power 0 and the base 10, because we are converting to the decimal numbers. So 2 to the power 4 we will actually calculate. That comes to 16, and 16 times 1 is 16. Then 2 to the power 2 we calculate. 2 times 2 times 2 is 8. 8 into 1 is 8. Again we do 2 into 2, 2 square. So 2 times 2 is 4, into 1 is 4. Then 0 into 2 times 1 is 0. And then 1 into 2 to the power 0 is 1. Okay. So again base 10. So these numbers we have got. And we got this answer as 20. We add them up and we get the answer as 29 to the base 10. You can do it actually, and then you will understand it now itself in the tabular form only. And then one basic maths to remember, arithmetic maths to remember here is any number to the power 0 is 1. Okay. 2 to the power 0 is 1. And 0 times any number is 0. But to any number to raise to the power of 0 is 1 and not 0. Okay. If you do this, the only mistake that happens here only, 2 to the power of 0 is most of the people write it as 0. Then their number, because one digit straight away gets eliminated and their answer gets wrong. Okay. So this is one thing which is very important, needs to be remembered. You can do it and just tell me now itself. Are you doing it? Yes, are you doing?
Yes. माझं झालं. मॅम मी केलं.
Okay.
मी पण केलं.
Okay. So you got it?
Yeah.
Yes.
Yeah.
So you have to remember any number raised to the power 0, 2 to the power 0 is always 1, and number multiplied by 0 is always 0. And this base here we took 2 because the question was like convert from binary to decimal. If the question was octal, we will take the base as 8, then all these 2 will be replaced by 8. If they say hexadecimal, base is 16, then all these 2's will be replaced by 16. And we have to actually do those big calculations, like 16 into 16 into 16 4 times. That all we have to do. Okay,
Yes.
manually. But nowadays, nobody does it manually, and this is not used also. But in exam, we have to do. Yeah, so here decimal to binary conversions, I have given some few solved examples, which you can do it by yourself. Yeah, you have to remember till what point you have to divide. Okay, like till your quotient becomes less than the base, and then straight away take that quotient. Okay, as the part of your digit, and then go from bottom up, not top to bottom. Yeah, bottom up. That is one step you have to remember. So here are like few examples which are solved. You can solve by yourself and check the answers. Sorry, I skipped one thing. Now, earlier we went from decimal to binary. Now we are going from binary to decimal. That also I showed you one example earlier. What we do when we are going from binary to decimal, we multiply by the power, because if base is 2, then 2 to the power. The units place we take 2 to the power 0. After that tens we take 2 to the power 1. Hundreds place we take 2 to the power 2. Thousands we take 2 to the power 3. Then 10,000 we take 2 to the power 4 and multiply with whatever digit is there. If 0 is there, multiply by 0. 1 is there, multiply by 1. And then whatever calculated answers you get, you add them. So it's always, better to write in the tabular form only, so that you can do the calculations in the exam also. Even in the rough work, whatever you do, you better write in the tabular form. Adding numbers becomes in vertical format becomes easy, and there are less chances of us going wrong in that. And again, the arithmetic algebra to remember is anything raised to the power 0 is 1, and any number multiplied by 0 is 0. So that is the only mistake that people do here. So this is again the same thing is shown, and you get these numbers, you have to sum these numbers. To get these big numbers, you will get big numbers now, because we are going from that small binary number system to the decimal number system. Then binary to octal. So binary, when see I always prefer going by this easy method. It might be little bit long, but I prefer going by this method, because there are less chances of us making any mistake. So binary to octal, what we should do is you convert that binary first to decimal form, which we know. Okay, and then decimal numbers you start dividing by 8, because decimal, again, from decimal to any other number system, we start dividing by the base. Again, the steps are the same. Like how we divided by 2, we divide by 8. Till what point we have to divide? Till the quotient becomes less than the base. When the quotient becomes less than the base, straight away take that quotient and put it in the as a form of the number digit in the number, and you will get your answer, and go again bottom up. Yeah, so here I'll explain the steps again. We were given a binary number, okay? 1, 0, 0, 1, 0, 2, and we were told it has base 2. So they might not write this word as binary number. They will give this base here. So from that we have to understand this is binary number, okay? And they might say, okay, convert it to octal, or they might sometimes just give an empty bracket and say, okay, at the base there is 8. That is where we will get to know that, okay, we have to convert to octal system, or sometimes they will write a small 16 there. Then we come to know, okay, convert to hexadecimal, and sometimes they write 10, then it is decimal. So if it is converting to the 10, the decimal number system, which is like our layman's and layman's number system, then it is very easy. But then when they go beyond it and say convert to some other number system, then we have to follow 2 steps. So first we have got this number 100101 base 2. We will convert it to the decimal number. Okay, the numbers that we know. So we do like, we count how many digits are there. 1, 2, 3, 4, 5, 6, 7. So we know 7 digits. So when we start from the left hand side, so the lowest first units digit will have 2 to the power 0 as the multiple. Okay, 2 to the power of 0. So the leftmost bit will have the multiple power as 2 raised to, there are 7 digits, but the highest power will be 2 raised to 6. Okay, because we are starting from 0. And then we follow our Sanatani style. We will start from left hand side. So 1 times 2 raised to 6 plus 0 times 2 raised to 5 plus 1 times 2 raised to 4 plus 1 times 2 raised to 3 plus 0 times 1 times 2 raised to 2 plus 0 times 2 raised to 1, and the last digit 1. 1 into 2 raised to 0. Again, it is better to write this vertically only. I did not have space on the screen, that's why I have done this horizontal, but better to write vertically, so that we get we are first time right. Then we have to do those calculations of 2 to the power 6, which is 64. Then 0 multiplied by any number 0. Then 2 to the power 16 multiplied by 1, it will be same number. Then was 0 into 2 raised to 3, so 0. Then was 1 into 2 square, so 4. Then 0 into 2 raised to 1, again 0. 0 in multiplication 0. Now comes that tricky bit, 1 into 2 to the power 0, and always number raised to 0 is 1. So 1 times 1 is 1, and you add these decimal digits, you get the final 85. 64 plus 21, 85. So now we know this decimal number, which as a layman we understand. Okay, so all these 0, 1, 0, 1, 0, 1 to the base 2 given to the computer is actually number 85. But now our question is, no, we don't want to stop here. Actually, in exam, what they give is, they give this 80 pi also as an option, you know, to confuse people. So we come to this first answer, and in the rush, we will click 85 and our answer will go wrong because they want it to be converted to base 8. So we have to take this decimal number, which is our layman's number, and start dividing it by the base. Okay, until what point you keep on dividing, and you write all those reminders in the last column. Second column, you keep on writing the quotients. And when the moment, like here we did 8 divided by 85, 8 ones are 8, 8 tens are 80. So remainder was 5. Now again this quotient is 10. So we are 8, 8 is less than 10. So 8 divided by 10 here, 8 ones are 8, we got remainder as 2. Then again the quotient, we are interested in the quotient. We saw this quotient 1 and it is less than 8. That means straight away we'll write the quotient in the last column in the remainder, the lowest bit. And then we will go upside down, bottom up order. So the octal equivalent is 1, 2, 5 now. You can do it with paper. Do it yourself now itself. You will understand this step. Can you do it now? I'll wait here for 1 minute.
Yeah.
And please write that decimal conversion also vertically. It will be easier for you. Like how this is written now, write it vertically.
I got it, ma'am.
Yeah, Archana ma'am. Ma'am, are you there?
येस, मला आता अजून समजलं नाहीये, थोडं माझं कन्फ्युजन होतंय.
हा, कुठे होतंय मॅम? वेअर इट इज?
हे हीच ती जी अमाऊंट घेतली ना, अमाऊंट म्हणजे सम्स
हा.
0.0112 10.5 हे मला थोडं कन्फ्युज झालं. हे वरचं समजलं.
हा. Ha, Ata, see, what you do, you know, here I had shown these steps now. You too like this. See, like this. Like this, you make a table and start dividing by 8. 85 divided by 8.
85 डिवाइड, हा.
Like this, make a table and start dividing. 80, here 29 divided by 2 is there. You have 85 divided by 8. So write whatever quotient you get in the quotient column, whatever remainder you get in the remainder column.
Yes.
Yeah, do follow the mechanical procedure. Nothing in this. Only do the mechanical process. Yeah, you got next quotient. You got it as what? 8 tens are 80, right there. So 10. So step 2 is 10 divided by 8. Did you write that?
एक सेकंड, मी तो टेबल माझ्या ह्याच्यातला शोधते.
No, you just draw a table, a rough table, because like that only we'll do in the exam, right? We don't need all this rough work, no? $85 divided by 2, quotient is 10, remainder is 5.
5.
Yeah, then come to step 2. So second row, now take that 10. 10 divided by 8. 10 is greater than 8. So we have to continue dividing. So now 10 divided by 8 is what? 8 ones are 8 and remainder 2. Right?
Yes.
Now we go to step 3. Now what we see? We are interested in that quotient. Now quotient is 1. It is less than the base 8. Right? That means we have come to the end now. So 1, that quotient you will write in the remainder column in step 3. Did you write that?
नाही, एक मिनिट परत सांग. हे
Step 2 we are there, right?
हा.
10 divided by 8.
हा.
So now 8 ones are 8, right?
Yes.
So quotient is 1 and remainder column is 2. Did you write that? Right? Now again we are going to step 3. So we are looking at the quotient. So we say 1 divided by 8 now. Right?
Yes.
But now then we realize, oh, 1 is less than 8. That means over. The process is over now. So we straight away take that 1 and write it under the remainder.
Yes.
And under the quotient, we write 0 and close this. So, and go from bottom up. Bottom up, right? So what is our number there? Bottom up, we get what? 125, right?
Right.
125. So 125 is the octal equivalent, okay, of that binary, what, 10101 or decimal 85. Did you get it?
Yes.
So this is mechanical process. Not to think much about it. Just follow these two mechanical processes of going from decimal to binary or any other number system and coming back from other system to decimal. Yeah.
Yes.
And then in here, yellow box, what I have given is the, now we did right from binary to octal. We went into binary to digital and from digital to octal. So now the questions sometimes are come back from octal to binary. Yeah. So we have this octal 125, which we found out now as base 8 to decimal. So when we are converting from base, any other base to our layman's decimal system. So we will take those digits and start multiplying with the base and the power. So here we see what? 1, 2, 3, right? 3 digits are there. So we know that 3 digits and base is 8. So right hand side units place will start with 8 raised to 0. To second place we will have 8 raised to 1 and third place will be 8 raised to 2. So we have to start from 8 raised to 2, right? 3 digits. But units place will start from 0. So 8 to the power 2. And then writing, we always start from the left hand side, Sanatani way. So we'll start from the leftmost digit, which is 1. So 1 times 8 to the power 2. Then second digit, 2 times 8 to the power 1. Third digit, units place digit, 5 into 5 into 8 to the power 0. And then you have to do the manual calculations, and whatever you do addition, you will again get that 85 base 10, 85 decimal number, and that we will convert to binary again by dividing by 2 things and going up, bottom up. And then you will again come to the same binary number. You want to try doing this, coming back from octal to binary with the same number?
Yes.
Then start, because now our answer was 1 to 5 octal, right? Now take 1 to 5 as an octal, and the question is go from octal to binary. So whenever from any number system we are going to the other number system, what we say that for decimal, if the decimal will come to the decimal number in between, and from decimal we'll go to the other system. This becomes easier. Some people do it directly also, but then there is a lot of complicated logic to remember. This is like very basic mechanical procedure, very less chances to go wrong in this.
ये easy है.
Do this 2 step. People teach direct methods also, but then there is too many things to remember for just 1 or 2 marks.
तो हम लोगों को बहुत प्रैक्टिस करनी पड़ेगी, लेकिन ये आएगा समझ में, मतलब प्रैक्टिस करने के बाद समझ में.
Means going to decimal, we have to remember multiply by the base. Yes. Coming to decimal, and from decimal going to the other system means dividing by that other base. Right? From decimal to other system, divide by the other system's base. And when you are coming from any other base to decimal, multiply by that base. That you have to remember. I remember like D to something means divide. D to something means divide. And we never divide by 10 here. See, we are always dividing by those other bases, right? By 2, by 8, by 16. So D to something means divide by that other base. And when we are coming from any other system to decimal system, which is our layman system, then it is multiply by that base. Then it becomes very mechanical, and focusing on the quotients and then writing the remainders and going up bottom up. That steps we have to remember. When we are dealing with 1, 0 and all that, we have to go from bottom up. When we are dealing with the remainders now, always go from bottom up. Then your number sequences the bit sequence is always correct. Okay?
Yes,
Got
ma'am.
Yeah. Then next, like why we are doing all these octal systems and hexadecimal systems, like we have this large binary numbers, like how many digits are these? 16 digits in this number. So like the computer has to handle like these big numbers. So they are compressed by using this octal system. Like for say this binary system required 16 bits, right? 16 bits to for this number. But when we are writing with octal, see it required only 6 bits, grouped by 3 bits, right? 170253. And when we go to hexadecimal, can you see the number system? Number have become so small now. F0AB, grouped by 4 bits. So that's why we have to learn. That's why computer needs these octal systems and hexadecimal systems. And beyond that, ASCII and all those other number systems. So that they can write the numbers in a very small, in a very compact space, because memory is very expensive. So you want to save all that space. That's why all these number systems. Okay. Otherwise, computer is very fast. For him, handling these many 16 bits is also not a big deal. But we want to save the space, the memory, which is very expensive. That's why so many number systems. Yeah, that's it. Done for today. Yeah, if you have any questions, you can ask me now as well as afterwards on the group. And yeah, I was a bit fast in between, but then the time was a constraint. Okay, thank you, everybody. Thanks for the cooperation.
Thank you.
Thank you, Pratik.
Very nice. Thanks.
Thank you.
So,
Kiran
Pragati,
ma'am? Yeah. Kiran ma'am, are you there? Can we do the prayer and close?
yes. आपने अच्छा लिया.
तालियां
अच्छा
बजा रहे हैं.
Oh, thank you, ma'am. Yes, ma'am, you do the prayer and then we'll close. Yeah.
चल कर लेते प्रयास.
Yeah.
बैठ जाएंगे ध्यानात्मक आसन में. पीठ गर्दन कमर स्ट्रेट. आंखें कोमलता से बंद. मन एकदम शांत. एक गहरी लंबी सांस लेंगे और धीरे धीरे छोड़ेंगे. एक ओम का उच्चारण करेंगे. ओम. असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतं गमय. ओम शांति शांति शांति. इस भाव को फील करते हुए दोनों हाथ एक दूसरे पे रब करेंगे और अपनी आंखों पे लगाएंगे और एक हल्की सी स्माइल के साथ धीरे धीरे अपनी आंखें खोलेंगे. थैंक यू
Thank you, Pragati ma'am. खूप छान, खूप छान.
मला माहिती आहे न्यूमेरिकल्स आहेत, सो सॉल्व करून बघायला लागतील, तर तुम्ही अजून थोडे बघा. मी सॉल्व पण काही करून ठेवले.
एकच विचारते. F0AB, the value will come. F value is 15. Then the zero's value will be 0, A's value will be 10, and B's value will be 11. I'm just asking, you should sum them up, then ती संख्या नाही, चुकतंय माझं काहीतरी.
नाही मॅम, तुम्ही आता सुरुवातीला दिलेला नंबर बघा. 1111. F झाला 1111. F 0 आहे तो इकडे सरळ आहे. 0000. A आहे तो 10 आहे, म्हणजे 8421. 8 प्लस 2 raised to 3. 8, right? 2 raised to 3, 8 plus 2 raised to 4 into 00 plus हे इथे किती झालं? 2 raised to 1 into 2, right? मग झालं 8 आणि 2 10. A is 10 ना?
Yeah.
B
A is 10.
बी आहे 1011 म्हणजे इथे 2⁻0 नी मल्टिप्लाय होणार, इथे 2⁻1 2⁻3 आणि 2⁻2 आणि 2⁻3 येणार इथे, राईट. 2⁻3 into 1 म्हणजे 8 into 1, राईट. इथे 2⁻1 into 1 म्हणजे 2 म्हणजे 8 + 2 10 आणि इंटू 2⁻0 आहे 1 म्हणजे 11 म्हणजे बी, राईट.
Yeah.
तसं मॅप होतो.
11 is B.
हा तसं मॅप होतो तो.
Okay.
ओके
Thanks.
ओके.
Bye. आज लेक्चर आहे 4:30चं, नाही ना?
हो आहे
आहे. ओके.
सकाळीच टाकले.
ओके. Thanks.
थँक्यू एव्हरीबडी. थँक्यू सो मच. बाय बाय.
Thank you, Pragati. Thanks.